Alright, next method we're going to talk about is completing the square. I'll talk to you a little bit about when I use it and stuff like that here in a second, but first of all we need to get to basically the basics of what we're trying to do. So in completing the square, it's basically another method that we can use. We've already looked at two, so we've already looked at taking the square root to find our solution, and we should know that you can only use that when you have one variable. We've also looked at how to factor. Now, the unfortunate part is I factor anytime I can, but not everything's factorable. So two numbers that will multiply to give me 4, that will add to give me -6, that's not going to work. 1 and 4 will add to give us 5, 2 and 2 will add to give us 4. So unfortunately this one is unfactorable. So now we need to still be able to figure out how to find solutions to quadratics like this. And one of the methods is completing the square. Completing the square is going to work all the time. We'll talk about that here in a little bit. So what we're going to do first is we're going to group our variables and move the constant to the other side. Well, here's our nice little variables. So you can see those are our variables. We're going to move our constant to the other side. So let's see if we can't do that. What I would need to do, so move it over there. What I would do is I would factor out the leading coefficient from both variables. Okay, so this is a little bit different than what you might expect because we have already studied a couple times factoring out the common factor, but that's not what I'm going for here. I'm actually factoring out the leading coefficient. So in that case, if it's in standard form like this, A is going to be our leading coefficient. Right now, this problem has a leading coefficient of 1. So if I factor out this 1, that's basically going to divide both those by 1. It's not going to change my problem. But it will change our problem if it's 2 or 3 or something like that. So just something to be aware of. Just make sure that you understand that. Because, yeah, it will change your problem if you don't do that. Next, what we're going to do is we're going to take half of b and write it as the second term of a binomial. Okay? So what we're going to do, we're actually going to make up our problem. All right? Sometimes in life, we know where we want to go before we know how to get there. You know, I'm sure some of you guys are at this point where you're like, man, I really want to go to this school. And then you should be going back and saying, well, you know, what do I need to get in terms of my GPA? What do I need to get on my ACT? What classes do I need to take to be ready to go to a college like this? So sometimes you know where you're going before you know how to get there. And we're going to make it up. So it should be fun. Let's see. Take half of b and write as the second term of a binomial. B is the linear coefficient in a problem like this, the -6. When you take half of -6, you'll get -3. So kind of keep that in mind. And what we're going to do is we're basically going to make up a trinomial that will factor the way we want it to. So keep that in mind. We're making up this trinomial. So we had something that was unfactorable, and now we're going to make up something that is factorable so that it'll factor just how we want it to factor. So we want it to factor to x minus 3 times x minus 3, or that squared binomial. So to do that, x times x would give us x squared, x times -3, -3x, -3 times x is -3x, which is -9 or -6x, and then -3 times -3 would be a +9. Okay, so what we need to do is we need to take that answer and square it to get the third term of our trinomial. So as you can see, I squared that here. What I need to do now, hopefully it'll move over to the next slide here, is after we square the number, multiply the answer by the leading coefficient and add it to the other side. So I guess I probably shouldn't have erased some of this stuff, or that's okay. So whatever I get here, this number, I always multiply it by my leading coefficient. Okay, so 9 times 1 is 9. So whatever that number is, I have to add it to the same side or to the other side because I really need to balance my equation. If I don't, obviously my equation, I can't just add 9 here and not add 9 there and have it still be a true equation. So what I'm going to do now is I'm going to go ahead and combine these like terms. So that will give me a +5. All right. Now, the good news about completing the square is we've manipulated our problem so that now we can solve it. And the reason we like this one a lot better is because now there's only one variable. So I can solve for that one variable. I'll take the square root. I should divide it by 1 first, but that's okay. We get x minus 3 is equal to, remember it's always plus or minus, the square root of 5. And then lastly, I'll solve for x by adding that 3. All right. So that's one example of basically completing the square. Don't worry, we'll look at a couple more.